Okay, today we're working on the 7.2 inverse trig functions notes and problems. While we're studying this, this section covers the inverses of secant, cosecant, and cotangent, and more problems involving the inverse trig functions involving two different ones. Applications include the angle of repose with de-icing salt, having to do with potential transportation issues, the angle of repose having to do with the bunker sand, and also artillery. So the angle of repose is the naturally occurring angle of slope measured from the horizontal at which loose material comes to rest. It's usually shaped like a cone, and it's the equation theta equal cotan negative 1 r over h, where r is the radius and h is the height. Now I know I'm a terrible artist, but I'll try to show you what I mean by this. This description was in your book, so act like this is a bulldozer. And it's got, that piece up here. Well, let's just say there was dirt in there or gravel or whatever. When it dumps it out, here's your ground, and it naturally makes a cone there. And so this angle from here to here is called the angle of repose. It's from the ground level to whatever the level there is. So this would be the dirt, the gravel, or whatever. Okay, so your objectives are to find your exact value of trig functions involving the inverse sine, cosine, and tangent. And also to define your secant, cosecant, and cotangent and use a calculator to evaluate them, and to be able to write a trig expression as an algebraic expression. Okay, so how we start with this is the following. When finding the exact value of expressions, let theta equal the inside expression. It's g of x on f of g of x. Then the next part, pay attention to the interval required from 7,1. So remember about that. All right, so pay attention to the interval. So what we said about that is like sine negative 1 was from negative pi halves to pi halves. Tan negative 1 was similar to that, but it's with parentheses instead because of the asymptotes. And cosine negative 1 was from 0 to pi. So those are just a reminder from 7.1. Then you're going to graph the triangle in the appropriate quadrant and use the Pythagorean theorem to find the radius, and then use your appropriate formula, like sine is y over r, or you could think of that as opposite over hypotenuse. I'll do an example of my own here. So, for example, you could have some random trig function in front. I don't care if it's sine or cosine. In this case, I'm going to put cosine. And then on my example, I'm going to say tan negative 1 of 8. So this is how you'd go about it. And I'm trying to explain the notes this way. It says let theta equal the inside expression. So if you want to write that step, it'd be theta equal tan negative 1/8, which basically means tan theta equal 8. Because remember from last lesson, to get rid of a tan negative 1, you do tan to both sides for them to cancel. Okay, and this is where you have to remember some things we did earlier in the year. Like we called 8 like 8 over 1. Okay? And we know tangent was opposite over adjacent. The next thing we would do is draw your quadrant, and we know tangent was positive in this one where it's everything positive, and tangent is positive here because it's negative comma negative. So this is basically combining a bunch of lessons into one. So again, if it's a whole number, put it over 1, and then tangent is opposite over adjacent. So now, based on what we did over here, we said tan negative 1 is from negative pi halves to pi halves. So 0 is here, pi halves is here, pi is here, 3 pi over 2, which is also negative pi halves. So we care about being in this side. So since we want tangent to be positive 8, then it's got to be like this. So normally your triangle, if it's going to be sine or sine or tangent, it's going to be on the right side of the y-axis. So even though tangent can be positive here, that's outside of our interval, because our interval is negative pi halves to pi halves. So then we say our opposite is 8 and our adjacent is 1. Then you do your Pythagorean theorem. So you'd say 1 squared plus 8 squared gives you 65. And so that'd be the square root of 65. So our hypotenuse, which is our radius, is the square root of 65. And then that basically is used to draw the triangle. The inside part is used to draw the triangle. Now that we have the triangle drawn, then whatever trig function is out here, we have to apply to the triangle. So since it's cosine, we're going to use adjacent over hypotenuse. So cosine is adjacent over hypotenuse, which would be 1 over square root of 6. So that'd be square root of 6 over 6. Oh, that's 65. Sorry. Square root of 65 over 65. So basically wanted to show you all that because that's summarized here. Theta was the inside. Pay attention to the interval. If it's sine or sine or tangent, you're going to use this. If it's cosine, you're going to use one of these, because you need a place where cosine is positive and negative. So that's why it has to be a different interval. And then you're going to graph, then you're going to do your Pythagorean theorem, and then you do your trig function. Any questions? Okay, so now defining secant, y equals secant negative 1 of x means x equals secant y, S-E-C-Y, where absolute value of x is greater than or equal to 1, and then you're from 0 to pi like you were for cosine. Remember this absolute value thing was because when we did secant, it was some of them were above 1 and some were below negative 1. And so remember previously you chose the or part for the range where it's greater than or equal to 1 or less than or equal to negative 1. Well, that is still also the same thing as absolute value of x is greater than or equal to 1. It's a different way to put it. It means x is greater than or equal to 1 or it's less than or equal to negative 1. So you change your sign. Alright, so there's your secant. The next one is CSC, so that's cosecant. Y equal inverse cosecant means x equal cosecant y. And there's your intervals. Again, going from negative pi halves to pi halves. Inverse cotangent means x equal cotangent y, where that's your interval. So this part is like cosine, and this part is from tangent. So it kind of combines that. Cotangent is sort of like cosine and tangent. All right, number 5. For y'all, these are going to be easy. Most calculators don't have what y'all have. For y'all, it's going to be easy because all you do is you go to the trig button and then you use this bottom row, which even has cosecant -1, secant -1, etc. But all these older calculators only have sine -1, cosine -1, and tan -1. And so if you have a weird question like secant -1 of 3 and you didn't have this type calculator, you'd have to change secant to cosine, which is like flipping, and then you have to change your 3 to 1/3, which is flipping also. So you have to find out an equivalent one. That's not that easy, so like if you can, save up money or use part of your scholarship money to buy a CX2 if possible. Because the 84 plus calculators don't have some of these features that you might want. The easiest way to evaluate them is to convert to an inverse trig function whose range is the same as the one to be evaluated. And like I said, secant -1 of 3 is equivalent to cosine -1 of 1/3. Let's just do that real quick to prove it. Secant -1, 3, enter. So it's 1.23, and then if you do 1 over trig cosine -1, 1/3. Oh, I did that wrong. I didn't type that right. Cosine -1, 1/3. That's the 1.23 also. So those are equivalent. So it is possible to do that on the other calculator if you need to. It's just you got to require more thought. Okay, so now let's start writing the problem numbers, which are these, and get set up for that. Okay, so now for your problem numbers, 7-2, page 457, numbers 4 through 8, which are your vocab type questions, then 10 to 54, every other even. So number 4, y equal secant -1x means x equals secant y, where this is basically straight from your notes that we just did. Absolute value of x greater than or equal to 1 and 0 less than or equal to y less than or equal to pi, and y cannot be pi halves. I'd like you to write that whole sentence, but the reason for the pi halves is because of the vertical asymptote at pi halves. So what that looked like was one here and one here, and this is the one that's at pi halves. You don't have to. Thanks. Okay, so that's number 4. Number 5, inverse secant relates to inverse what? Inverse secant relates to inverse what? It won't be sine because that's S to S. It's cosine because the C and S go together. So again, there's your sentence. Okay, number 6, true-false question. It's impossible to find exact answers for secant -1. That's false. I know sometimes people may get frustrated, but I basically just said how we're going to do it. You draw your triangle and do the Pythagorean theorem. So there is an exact process. Don't just give up. It's not impossible to find it. Okay, number 7, true, false. Is cosecant number -1 of 0.5 defined? Is cosecant -1, like inverse cosecant of 0.5, defined? Easiest way to do this is on the calculator. So go trig, find cosecant -1 down there, and put 0.5 and undefined. On y'all's calculator, it may say non-real calculation, but that's the same thing. So it's undefined, so no. However you want to word that, I don't care. Okay, number 8, true, false. The domain of cotan -1 is all reals. Is that true or false? So like on 7, I could have put false, but I don't care if you put false or no. I don't really care. On 8, true, false, the domain of cotan -1 is all reals. Let's graph it and see. So graph cotan -1 of x. Okay, so it looks like that, and so that would be true, that the domain is all reals. And that looks sort of like this. You don't have to draw the graph if you don't want to. Okay, so now we're getting into the other problems on this. You want to find your exact value and draw the triangle based on the inside. Okay, so this one you have sine cosine -1 1/2. So these say find the exact value. So I'm going to lead you through this process for how we get it. So like in the notes we said, you say theta is equal to this, which means for my step 1, I'm just going to say cosine theta equal 1/2. I'm not going to write the part which said theta equal cosine -1 because automatically we want to jump to this step. I mean, if you really need it, you have theta equal cosine -1 of 1/2. But then immediately just change it to this where it's that same function and put theta. Okay, so cosine theta is 1/2. So cosine is the adjacent over the hypotenuse, and cosine is positive wherever x is positive, so that'd be there as well as there. And we know that the interval basically goes from quadrant 1 and 2 like this, because it's from 0 to pi. And so because it's a positive 1/2, that means I'm going to use this one. It's not a negative 1/2. So again, it tells you cosine is 1/2, which meant it'd be on the right somewhere, either above or below. But based on our interval for cosine -1, it's got to be on the top side, which is in quadrant 1 or 2. So your interval is from 0 to pi. Okay, so now label 1 as the adjacent, and like we said before, the adjacent is always on the x-axis, and the hypotenuse would be across from 90, and so then you can do your Pythagorean theorem. Since it's a vertical one, a vertical line, I'm going to call it y instead of x. So then you'd say y squared plus 1 squared equal 2 squared. Y squared plus 1 equal 4. Y squared is 3, and you get plus and minus the square root of 3. And based on being above the x-axis, it's got to be positive square root of 3. So I'm going to cross out y, and I'm going to put square root of 3. So that's your first step. Any questions? Okay, your second step is do sine of the triangle, basically. So basically, sine is the opposite over hypotenuse, and so your opposite is square root of 3, and your hypotenuse is 2. And so that's your exact answer. So this method with these two steps, so to speak, will always work. You draw your triangle, and then you do whatever trig function is to that triangle. Now, for those that like to try things in a different way, which is okay, if you did sine, cosine -1, 1/2 on your calculator, you would have gotten 0.866 something, and then you could say, oh, I recognize that as square root of 3 over 2. And so then you don't have to do all that work. But sometimes it may be decimals you don't recognize. Like it could be 1.15 or something even weirder. So that's why I'm saying learn the real method to solve these problems. Any questions? So these we want exact answers. If it says exact, then you probably ought to do it the right way. Unless you're just good at figuring out like trial and error on your calculator. Okay, number 14. This one is cotangent of sine -1 of -1/2. Okay, so on this one, we'd say sine theta equal -1/2. And sine is negative here and here. And remember, the interval is basically the right side. So whenever it's sine or tangent, you're going to have to use the right side, not the left side. Okay, so as I was saying, if it's sine or tangent, you're going to be on the right side. We want sine negative, so it's got to be below here, like that. And our opposite would have to be the -1, and our hypotenuse would be the 2. Okay, so then you do your Pythagorean theorem. Since it's a horizontal since it's a horizontal distance we don't know, I'm going to call it x. So I'll say x squared plus -1 squared equal 2 squared. So that's x squared plus 1 equal 4. Again, just cut to the chase. Plus and minus square root of 3. And because it's to the right, which is positive, we're going to use positive square root of 3. So you drew your triangle based on the inside stuff. You had to figure out what quadrant, and then we had to do the Pythagorean theorem. Now we do cotangent to that. And so I know tangent would be opposite over adjacent, so cotangent would be adjacent over opposite. So this is your angle. Your angle always touches the origin. And the -1 is the opposite, and the square root of 3 is the adjacent. So we've got to put the square root of 3 over -1. But then you may as well just simplify that to negative square root of 3. And that's your answer. So that's all the work for it. And if you just tried, typing it, you would have gotten -1.73 something, and then had to figure out that's the negative square root of 3. Any questions about that? Okay, number 18. This time you're doing cosine of sine -1 of negative square root of 3 over 2. Cosine of inverse sine. By the way, sometimes instead of calling it inverse sine, they call it arc sine. And instead of inverse cosine, they call it arc cosine. It's just a random thing. So here we'd say sine theta is negative square root of 3 over 2. Sine is negative below the x-axis because sine relates to y. And we know we have to be in this quadrant based on our interval. Because our interval is basically the right side. So here's this, and we know it's opposite over hypotenuse. Sine is opposite over hypotenuse. So your opposite is going to be negative square root of 3, which is down here. It makes sense it's negative because it's below the axis. And your hypotenuse always is positive. That's how I knew to put the negative with the top instead of the bottom, because your hypotenuse always has to be positive. So then call this x and do your Pythagorean theorem, and you'll recognize this really fast. X squared plus 3 equal 4, so it'll be plus and minus 1. And based on where we are, it's going to be a 1. So if you see square root of 3 and 2, the other one's probably 1. I mean, we've now done that a few times. This time we had 1 and 2, and so it was square root of 3. So try to get in the habit of picking up on those patterns. Okay, so now that the triangle's drawn, then we do cosine to that. So cosine is the adjacent over the hypotenuse, which would be 1/2. Now on this one, everybody would have been getting this one like so fast if you just typed it. Go to cosine of sine negative 1 negative square root of 3 over 2. So if you type that, you would have got 0.5. And remember, even on the Math Excel, it wants fractions, and so you'd have to make that a half, like 1 over 2. But that's one where you really could have typed it and just gotten your answer. Make sure you answer in terms of a fraction. Oh, adjacent. Okay, that looks like a good stopping point for today. So we'll start the next one next time.